Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over a problem where you're going to calculate how many atoms are present in 1 meter length of a 20 gauge copper wire. And so with this problem, it says it's asking how many copper atoms are present in a 1.00 meter length of a 20 gauge copper wire. And then they give you some information. They say that they give you that 20 gauge wire has a certain diameter. So there's the diameter in inches. They give you the density of copper, 8.92 grams per centimeter cubed, and the mass of copper atom. And they give you 63.55 AMUs, which is the atomic mass unit used for very small things like atoms and molecules. So the first thing you want to do is you want to think of this as this wire of 1.00 meter length as a very long and thin cylinder. And so what you're going to want to do is eventually what we want to find is the mass of this copper wire, and then use the atomic mass of one atom as the molar mass of the copper wire, right? So then we can use molar mass. Molar mass is a relationship between moles and grams, right? So we could use that to find the number of atoms, right? Because if we can convert grams to moles and then moles to atoms, then we get our answer. But we need to find the mass of the copper wire, which means we're going to have to find the volume first and then use the density that they give us. So they give us the density right here. So if we could find the volume, we could use the density to convert that to mass, and then it's all downhill from there. So first things first, we need to know um, the volume formula for a cylinder. So let's write that down. So volume is equal to, and if you think of a cylinder as um, just a long tube, right? And then so the diameter of the tube stays the same, the area stays the same. So if you can find the area of the tube, then you can multiply that area by the length of the tube. Since we're assuming the diameter or thickness of the wire does not change. So it would be the area of a circle, right? We're assuming a cylinder, so it's a circular area. So that's pi r squared, so radius squared. And we're going to multiply that by the length of the tube. So it'd be multiplied by L for length. So that would be the volume formula for a cylinder. So if we could find the radius of our copper wire and we have the length, then we can plug that in and get the volume. And so we know the diameter in inches, right? So, and the radius is 1/2 of that diameter. So we can convert, we need this in centimeters because our diameter is in centimeters cubed. So we're going to have to convert everything into centimeters, our length into centimeters, our radius, our diameter into centimeters. So we want to take the diameter here. We're going to take 0.03196 inches, put it over 1, and then we need to convert that to centimeters. So we need a relationship between centimeters and inches. And so if you don't know this, this is a good one to know. It's very popular. We know that 1 inch is equal to 2.54 centimeters. And that is an exact relationship. It's true by definition. Um, so we're going to put inches on the bottom. Since we have inches on top, we want that to cancel out. So we're going to put 1 inch on the bottom and the 2.54 centimeters on top. So 2.54 centimeters on top. So inches cancels out. And what do we get? Let's use our calculator. Where's my calculator? Here we go. So we're going to take 0.03196 divided by, well, that's a 1. We don't need to divide it by 1. And we're going to multiply it by 2.54. 2.54 equals, and that gives us 0.08. So 0.0811778, and we'll leave it like that. And this is in centimeters. And again, we want to make sure that we have the right number of sig figs here. So when we're multiplying and dividing, the answer should have the same number of sig figs as the least number of sig figs in the numbers that you're multiplying by. So here we have 1, 2, 3, 4. This is 4 sig figs. The zeros at the beginning of a number, these leading zeros, are never significant, so we're not going to count them. So this is 4 sig figs. And here we have 3 sig figs. So the least number is 3, so we can only keep 3 sig figs here. 1, 2, 3. Again, the zeros are not significant, so we're not counting those. So we're going to start with the first number, 811. That's 3 sig figs, so we're going to have to stop there. We'll keep 1 or 2 extra digits to avoid rounding errors. So I underline it here to remind myself that I'm only allowed up to that second one. Okay, now that I have this, what I can do is divide this by 2, because this is the diameter. If I divide this by 2, then I'll get the radius. And since 2 is an exact number, it's not going to affect the number of significant figures. So let's take this number and divide by 2. So divide that by 2 equals, and I get 0.4. So 0.0405. Let's add another digit. 889. Okay, so again, we have 3 sig figs here, so I'm allowed only 3. 1, 2, 3. So I'm going to stop here. The 0 here is significant because it's between 2 non-zero numbers, so that's significant. So I underline the 5 to remind myself that I'm only allowed up to the 5. But again, I'm going to keep the 8 and 9 to avoid rounding errors. And again, this is going to be in centimeters. Can't forget the centimeters. Okay, so now I've got the radius. So I've got the R part. Length, I've got the length, which is 1.00 meters. I got to convert that to centimeters. And so I'm going to need another conversion factor. So remember, if I have meters and I want to convert it to centimeters, I need that relationship. And so it's a metric unit to a metric unit, metric length to metric length. And so I got to set up my equality. And the way I do that is I set up the 2 units. So I'm going to put meter on this side. I'll put centimeter on this side. And I always put a 1 with the prefix unit. So I'll put a 1 here. And then that way, if I know what the centimeter means, if I know what the prefix multiplier is, what does centi mean, then I can put that on the other side. I always put the prefix multiplier with the base unit. And so that way I never make a mistake. So the 1 goes with the centimeter. Centi is 1/100th of your base unit. In this case, it's meter. So 1/100th of a meter, or 10 to the negative 2. So I'm going to put 10 to the negative 2 there. So there's my equality. So now I can use that to convert. So I have 1.00 meters of my copper wire. I'm going to put that over 1. And I'm going to use my conversion factor. So meters is on the top, so I want meters on the bottom. So I'm going to put 10 to the negative 2, 10 to the negative 2 meters. And then 1 centimeter goes on top. So 1 centimeter goes on top. So meters cancels out. And now I can do my calculation. Okay, so here, if I do my calculation, 1 divided by 10 to the -2, and that's going to be 100, which makes sense because 1 meter is equal to 100 centimeters. So you didn't really need to do that. You could probably done this in your head, but it's nice to always practice our conversion factors and remind ourselves how to set up the conversion factor. So I have 100 centimeters here. I'm going to put a dot there because notice here that, again, I want to keep track of my sig figs. I have 1, 2, 3 significant figures here. These 2 zeros are significant at the end because there's a decimal point. So remember the rule. Does zeros at the end of your number, those trailing zeros, are significant if there is a decimal point. And we do have a decimal point. So this has 3 sig figs. This is an exact relationship, so that's going to be infinite, so we can ignore this. So that means our answer should have 3 sig figs. If I don't have the decimal there, then these zeros are not significant and it would only be 1 sig fig, but I want 3. So I need to have a decimal there to indicate that these zeros are significant. So that's why I have the decimal. Okay, so now I have the length, I have the radius, so now I can plug these values into my formula and calculate the volume. So let's go ahead and do that. So I have volume is going to be equal to pi times the radius squared, and the radius is this thing right there, 0.040589 squared, and then multiplied by the length, which is this right here, so 100 decimal point. Oh, I should never forget, I got centimeters here and centimeters here. So you'll notice right away that I got centimeters squared multiplied by centimeters. That's going to give me centimeters cubed, which is a volume unit. So I'm good. So now all I need to do is calculate. So multiply 100 times 0.040589. I'm going to square that. Equals, and I get, oops, I forgot pi. Can't forget pie. Everyone loves pie. Pumpkin pie, blueberry pie, apple pie. Okay, so I'm going to multiply by, where's my pi? There's pi. Equals, there we go, that's better. So I get 0.5. So that's equal to 0.5 17566 17566 ... We'll leave it there, and that's going to be centimeters cubed. Okay, excellent. All right, so now I have my volume of my copper wire, the 1 meter copper wire, in centimeters cubed. So now I can use the density to convert the volume to mass, and then I can use the molar mass to convert to moles, and then moles to atoms using Avogadro's number. So where should I put that? All right, so I'm going to take the volume. I have the density right here. So I'm going to take that and I'll have 0.517566 centimeters cubed over 1. And one thing I need to remember is significant figures here. So this has an infinite number of sig figs pi, so we don't worry about that. We have 3 sig figs here. We have 3 sig figs here. So that means we're allowed only 3 sig figs here. So 1, 2, 3, underline the 7. I'll keep the rest just to avoid a rounding mistake. So I'll underline the 7 here. So that's going to go over under 1, over 1. And then I'm going to use the density as a conversion factor. So this is telling me that 8.92 grams is equal to 1 centimeter cubed. So I want the volume on the bottom because I have centimeters cubed here. So I want centimeters cubed here, and that's going to be 1 centimeter cubed. So 1 centimeter cubed on the bottom, and the 8.92 grams on top. So 8.92 grams of your copper wire. And we'll put copper here. So grams of copper, millimeter or centimeters cubed of copper. So the centimeters cubed of copper cancels out. We're left with grams of copper. Excellent. So what's next? So grams, we can now convert grams to moles using the molar mass. Where do we get the molar mass? From here. So this is the atomic mass of one atom. This is what you get in your periodic table. But if you know the atomic mass, the same number for molar mass, and molar mass is the number of grams per 1 mole. So this is the number of AMU units for one atom. So per atom, it's the exact same number of grams per mole. So this tells us that if I have 63.55 grams of copper, that's equal to 1 mole of copper. So I can now use this relationship to convert grams to moles. So let's do that. So I'm going to put another conversion factor. So I have grams on top, grams of copper. So I'm going to put grams of copper on the bottom. So 63.55. So 63.55 grams of copper on the bottom, and then 1 mole of copper on top. So grams of copper cancel out. And now I have moles. And now all I need to do is convert moles to atoms. And I'm going to use Avogadro's number to do that. Avogadro's number is 1 mole is equal to 6.022 times 10 to the 23rd particles, or in this case, atoms. Right? So now I can use that relationship to convert to atoms of copper. So now I can have my last step. So 1 mole goes on the bottom. Since I have moles of copper here, I want 1 mole of copper. And the reason it's 1 mole is because I have 1 mole here. And then atoms is 6.022 times 10 to the 23rd. So 6.022 times 10 to the 23rd. And that's going to be atoms of copper. So moles of copper cancel out. I have atoms of copper. That is what they're asking for. How many atoms of copper are present? So I am done. So now all I need to do is calculate the answer. Let's get into this. So I'm going to take this number here, multiply that. So multiply that by 8.92. And then multiply by 1, multiply by that. Okay, so I'm going to multiply that by Avogadro's number, 6.022 times 10 to the 23rd equals, and now I'm going to divide by on the bottom, divided by 1, divided by 1, divided by, so divide that by 63.55 equals, and I get a large number, 4.374. 4.374. We'll add another digit, 7 times 10 to the 22nd atoms of copper. So that is my answer. Now, remember, that's only half the battle. So whenever you get the answer, you have to figure out the number of significant figures. And so remember, when you're multiplying, dividing, the number of sig figs in your answer has to be the same as the least number of sig figs in the numbers you are multiplying and dividing. So here I have this number here, but remember I underlined the 7, so this has 1, 2, 3 sig figs. So that has 3 sig figs there. Here they gave us the density, that has 3 sig figs as well. And they gave us the mass, that has 4 sig figs. That's the AMUs, the atomic mass. And here we have 4 sig figs as well. So the least number of sig figs is 3. So we can only keep 3. So 1, 2, 3. So we're allowed that there. 4, that's less than 5. So that means we keep the 7. So our final answer would be 4.37 times 10 to the 22nd atoms of copper. So that, ladies and gentlemen, is our final answer. I hope you enjoyed this. I hope you learned from this. If you like this video, please hit the like button over there. Subscribe to the channel. Leave a comment in the comment section. Let me know what you think. If you have any other questions or just want to leave a comment. Thank you very much. And thanks for joining me. Have a great day.